So, hello and good evening, everyone. I'm back again with another set of question answer round, you can say. So, last time we did with Unit 3. This time we are going to do with Unit 10. So, same rule. I'll show you the question. Try to analyze it yourself and we'll discuss. Okay. Now, see, in Unit 10, which is your ecology, here you will get a lot of questions from this section. Okay. Almost a total, you can expect some 4 to 5 questions from part B and around 4 to 5 questions from part C as well. Now, the questions are mainly of three kinds. Okay. One is a very straightforward question, completely theory based, which can be like based on some definitions, based on some experiments. It can be based on some principles. Okay. uh, Absolutely theory based. So if you have read it in the book or you have heard it in the class, you will be able to answer. So I'll just write it down for you. 1 minute. So you have some theory based questions. Okay. Or you can say the concept based questions. A very direct kind of questions. It can come for your part B also, it can come for your part C as well. Okay, in part C mostly these kinds of question comes in the form of a match the column kind. All right, where on one side they will give you the definition, on the other side they can give you the word. All right. So as I said, principle based, definition based, experiment based, or maybe some examples like particularly if you take the chapter as biomes, okay, biogeographical zones, that section if you take, then you have a lot of these examples uh, which can come from there. Okay. So theory based questions you get some numerical based questions. Okay, numerical questions, sum based questions, like you can get the sum based questions from your population growth. Okay, that is your population ecology. From there you can get it from your community based on the calculation of diversity, so Shannon index, Simpson index, all of that. You can get some numerical based question on population density as well. Life table calculations. Okay, but mainly you get, okay, and Lotka Volterra, which comes under species interaction. There also there is a bit of numerical, but so far they have not asked for the numericals. They have mostly give questions based on the logic, on the principle. Okay, but I have already mentioned this to my students that it's no harm in knowing how to do the calculations. Okay, because you don't know what is going to be asked, but this is one area where so far numerical question has not been asked. Okay, but there is a section of sums to be addressed to. Rest of it you don't have any numerical questions as such. And then comes the analytical questions. Okay, now in ecology, analytical questions mostly comes in the basis of graphs. So it can come in a paragraph also, like how it comes for the other units. But for ecology, most of the cases you will get in graphs. Okay, so these are the three kinds of questions you will get. Now, I will never say that you will only get the theory based question for your part B, not in part C, or the graph based question only for part C, not in part B. No, in part B, part C, in both the parts, you can get any of the three types of questions. Okay, so today let us go through some questions. So I hope everyone is ready. 1 minute, I'm not. Okay. So to start with, this is the first question. As you can see, this is a graph based question. But don't get scared looking at the graph. Many people they get scared immediately looking at the graph. Don't, because this is one example. Even though this is graph based question, if you just go through the question, you will see that it's very simple. It's very, very simple. So what do you think will be the answer here? What do you think will be the answer here? So they are saying the bubble plot shows an effect of temperature and precipitation on annual growth of trees of a certain species. The area of bubble is proportional to the tree growth. Based on the plot, the growth of the tree is. So on the x-axis you have the precipitation, on the y-axis you have the temperature. Come on, I'm expecting some answers from all of you. Let's make this interactive. Okay. The answer here is option 3. So you have to speak about the growth of the trees. All right. So growth of the trees is inversely proportional to precipitation but directly proportional to temperature. Let's see what is happening. If you see here, with precipitation, what is happening? The growth of the tree is reducing, isn't it? So as your precipitation is increasing, the growth is reducing. So it is inversely proportional, which is correct. With temperature, the growth is increasing, right? As you go up, see, look at the area of the tree growth, it is increasing. So it is directly proportional to the temperature. Okay. So see, it's so simple question. Very simple question. You don't even have to know the exact theory behind it. All right. Just analyzing the graph is enough. Now, this is a question from your species interaction. So, this is a matrix which shows the relationship between the probability of death and duration of species, and you have to put the species in the correct block. So, for this, you have to know who are called parasites, who are called parasitoids, who are grazers, who are predators, and so on. So, can I get some answers here? Okay, Vijayalakshmi is saying A. What about the others? So the correct answer here is option A. All right, because see, for parasites are what? They are the ones who live, who completes a part of their life cycle in the host, right, or on the host. It can be an internal parasite, it can be an external parasite. So accordingly, they are related to the host for the completion of their life cycle or part of the life cycle. But that doesn't mean that they are going to kill the host. Okay, so they don't kill the host, so the probability of uh, death is very low. Okay, but the duration of association is very high here. Next, parasitoids. Parasitoids are a group of parasites who definitely spends their life cycle within the host, and they kill the host. It can be that they are eating up the host, or maybe when they are coming out of the host, they are killing the host. But in the process, okay, of development, they cause death of the host. It is a it is a part of their growth process. So probability of death is definitely high here, and the association with the host is also very high because they are completing a part of it. Grazers. Grazers are like cows, okay, who doesn't, they eat the grass, but they don't uproot the grass. This is very important, okay. So if you're not uprooting the grass, you're just eating the fresh buds and the fresh leaves, okay, then obviously you're not killing the plant. The plant will again regrow its leaves, okay, but the plant is not dead. So the probability of death is very low, okay, and the duration of association is also very low because these grazers, they just don't focus on one particular plant. Rather, they move from one plant to another plant. Have you ever seen a cow grazing? They will go all over the place. They will just not sit at one place. Okay, I mean, eat from one place. They will go all over the place. Okay, so the duration of association is very low. But what about the predators? For the predators and the prey, okay, just take the tiger and the deer. It is definitely killing the deer. So the probability of death is very high. Okay, and the duration of association is very low because its only focus is to hunt the deer, eat it. That's it. It doesn't spend much time with the deer. So therefore, the duration of association with the deers or with the prey is very low. Okay. Now, going over to the next question. Again, this is a graph based question, but this is based on your population growth. So the birth rate B and the death rate D of the two species 1 and 2 in relation to population density are shown in the graph. Which of the following is not true about the density dependent effects on birth rates and death rates? So what should be your answer here? Try to analyze quickly, okay, because in your exam you also have to analyze quickly. So this is a practice session. So take up a statement related to the graph. In the first statement, they are saying that birth rates are density dependent in species 1 and density independent in species 2. So look at species 1 and species 2 birth rate. For species 1, density dependent or density independent? This is true. And mind it, they have asked for not true. Okay, be careful. They have asked for not true. So this statement is true. Okay, and density independent species, this is true. Because see here, the graph is going down. As the species is increasing, the population, the graph is going down. Okay, B1 is reducing. What about B2? It is stable. Okay, so birth rate is stable in species 2. The death rates are density dependent in both the species, which is correct. See, the death rate of species 1 and 2, it is changing in both the cases. Density dependent effect on birth rate is stronger in species 1 than 2. The density dependent effect on birth rate is stronger in species 1, which is correct, okay, than in 2. 2 is not influenced by the density. The density dependent effects on species on death rates are similar in both the cases, which is of course not the same, right? So this is also true, this is also true, this is also true. So not true is option 4. Next one. This is a numerical based question. So can you try it out? So see, in this case, they are saying that the research in a research on population dynamics of beetles, one student estimate that the population size is 3,000. Okay, over the course of a month, they have given you a time period. He records 400 births and 150 deaths in the population. Estimate the intrinsic rate of natural increase and calculate what the population size NT is predicted to be in 6 months. Right? So here they are, look at the data that is given to you. They're asking for NT, right? So which formula you should use? NT is equals to N0 e to the power of RT, right? Now N0 you already know. What is N0? This is your 3000. R, do you know what is R? Birth minus death, right? So that is your 400 minus 150. And T is already known to you, it's given 6 months. It's very simple calculation. So can you do the calculation? This is your answer. All right. So moving ahead. So we are launching a Josh batch. I hope by this now time you already know. All right. So those who are interested to join us, you can definitely join us. And you will get some internships to do, which are very important for your growth. All right. And you will get a lot of practice sets also, some question papers, and of course the revision tools as well. So the batch is starting on 1st of July. Meet you in the class. All right, moving on to the next one. So this is again a question on your population growth. Particularly, this is based on your life table. So do you know what is your life table? I hope all of you remember the formulas. If you remember the formula, let's see if you can answer this. So number alive, number dying, age specific survivorship, and fertility. So life table, particularly the reproductive table is included here. So you have to find out the reproductive rate R0. So are you solving it? Shall I do it for you or you have solved it? Okay. Vijay Lakshmi Gunsari is saying option 3. Others? All right, let me do this. The correct answer here is option 3. Okay. So what you do here is, now this is something which is very uncommon to many students, I will say. Like, unlike the population growth equations, those sums many of you are familiar with, but maybe you're not preparing for these kinds of sums which are also present in that particular population ecology chapter. Okay, so I'll do this for you. So see, you have nx, you have dx, and you have lx, right? So first, let us fill in these blanks. All right, let us fill in these blanks. Now, how to fill up these blanks? We have to use the data. We have to do some back calculations. Okay. So 20 minus 10. So number of alive minus number of dying will be the remaining in the next class. So 20 minus 10 is your 10. Okay. So here it will be 10. Now 10 have died, 20 have reached the next class. That means how many were alive? 20 plus 10, which is 30. All right. Now 50 minus something is 30. So that will be how much? 20. Okay, once you've got this, now we can calculate for your LX. Right? So LX is what? It is your NX by N0. Right? So 100 upon 100 is your 0. Okay, 50 by 100 is your zero point 0.5. 30 by 100 is your 0.3. Sorry, I made a mistake here. 1 minute. This is obviously 100 upon 100 is not 0, it is 1, right? So this is 1. 100 upon 100 is 1. Okay. So now uh, 10 upon 10 by 100 will be your zero point 0.1. Okay. Now, what is your R0? R0 is equals to summation of Lx into Mx. Okay. So therefore, this is going to be, let me just take out my calculator, or we can do it orally also. Basically, we do it orally, right? So this is your 0. 0.5 into 0.5 is your 0.25. So this is your 0.25. 0.3 into 0.5 is will be your 0.15. This is your 1.2 and this is your 1.1. Am I right? Oh no. See, I'm making such mistakes. This is 1, right? There is no 0.1. I'm not adding it up. So it's 0.2 and this is your 0.1. 1 into 0.1. Okay. So plus zero point 0.1 plus 0.15 plus 0.25. So this will give me the summation as zero point 0.7. Okay, so do your calculations correctly because otherwise you can go wrong. Got it? So your correct answer is 0.7. Now, moving on to the third question, sixth question. At third place, Vijayalakshmi, I didn't get this. At third place means? Okay, others, you can try out this next question. Question number 6. Try the question. See, unit 10, many people tend to leave out. One second, I'll just. No, Vijayalakshmi, it is into Lx into Mx. So it will not be point 0.3 plus 0.05. Where are you getting? It is already given as 0.5. Okay, zero point 0.3 into 0.5. Yeah, numbers are tricky. Numbers are very tricky. Okay, for this one, I already have an answer from Surtil. Who are you? Can you please rename yourself properly? So the correct answer here is A. Okay, so see, this is a graph based question as well as a theory based question too. You have to know the examples. Okay, you have to know the examples. So this is a graph, but this graph is nothing to analyze. This is already that is given the curves. Okay, the survivability curves which you have to study in the theory. Okay. So while you're studying it in the theory, then there itself you're analyzing the curve. Okay. So this is a theory based question, I will say. This is not the graph based question, but rather a theory based question. Okay. So they have given you the three survivorship curve, so, and they have given you the examples. You have to match it correctly. So marine pelagic fish and large mammals basically follow the type 3 and type 1 respectively. Now be careful. See here. Mammals, they definitely follow type 1. Okay? Which is correct. So if you look here, I'll show you something very interesting. If you see here in no other options, do you have mammal following type 1? Can you see? So even if you don't know pelagic fish, if you just remember mammals also, then also you will get the correct answer. Okay? If you're not sure about the pelagic fish, whether it be type 2 or type 3, then also you can hit the right answer. Because mammal is something known to all of us. Humans, mammals, they definitely follow type 1. Got it? Okay. So moving over to the next one. Now, this is a graph based question, but again, this is a theoretical based question. This is theory based question. In the class, I told you, I told everyone, I've also given you the graphs. There are different representation of the same idea based upon what is your x-axis and what is your y-axis. Just with the change of your x-axis and y-axis, the entire representation, the graphical representation changes. Logistic growth, exponential growth. Can you recollect? I even shared those graphs with you. So let's see who can give me the correct answer. Anyone who gives me the correct answer? Okay, the correct answer is option A. Okay. Okay, option A. When on the y axis you have population, this is an exponential growth curve. Okay, this is a logistic growth. Remember, this part is your k by 2, half of your carrying capacity, hyperbola. But what is the dimension given on the y axis? Logistic growth, normally we get the sigmoid growth curve, isn't it? But this is when you have dn by dt on the y axis. Okay, and this is again an exponential growth when you take an ln of n with time. So you can match this, those who has been my students and who have already received that graph chart, you can later on match it with your graphs also. And then remember, I told you in class that you should remember the dimensions. Okay, so you get these kinds of questions. Okay. Now moving on. So this is absolutely theory based. This is absolutely theory based. While you are studying, you can go through the derivations and everything, but that is just not required straight away. Just understand the graphs. Okay, just understand why you're getting a logistic curve and why you're getting a sigmoid curve and all the different types of curves when you're changing the x-axis and y-axis. Okay, there's no point wasting time in going into the derivation of these different kinds. No point of it. All right, moving on to a graph based question. Now, this is a graph based question. The previous two were not graph based but rather theory based. Though graphs were given, but I will categorize them as theory based. This is graph based because you have to analyze. And this is a question which has come from the niche, and this is one of my favorite questions because this truly tests your knowledge about niche as well as analyzing graphs. Observation, it tests your observation. So this is one of my favorite questions, graphical questions. And I want an answer from every one of you. Try this question. Everyone. See, I'm getting uh, almost the normal answers. Okay, Arzu has changed her option. Think, those who are giving me the option as C, think about it. You're missing out something. I told you, no, this is going to test your observation and analysis. A simple question based on a very simple topic, yet difficult. Difficult if you don't observe and analyze properly. So you want to know what is the answer? I'll give you 2 more minutes to think. See, they are saying followings are the niche characteristics of the constituent species and resource partitioning pattern in different ecosystem. Which of these would lead to competitive exclusion of species? When do you have competitive exclusion of species? When there is a niche overlap, isn't it? That means the same niche or the same resource is being shared by two species. Now, when the niche overlap percentage is very high, that is the time you're going to face a very high magnitude of competitive exclusion, high pressure here to exclude out. But if the overlap is very less, then obviously the competitive exclusion rate will be very low, right? So analyze the graphs. All of the graphs are talking about two species. This is a hint I can tell you. All the graphs are talking about two species interaction. There is no one species involved here. Two species interaction. I only have received the correct answer from two people. Yes, absolutely. Absolutely. Correct analysis. So the answer is B. Look here. I told you what is the hint I told you. Two species are, competing here. So this is a graph which is showing you that both the species are 100% overlap. 100%. Over here it is not 100%. There is this, this part is only overlapping. This part is only overlapping. Here only this part is overlapping. But here you can't make out the two species because both the species are overlapping their niche 100%. Is a complete overlap. Okay. So answer B is the correct answer. So observe it very carefully and mind it. Many of you must be thinking that there is only one curve here, so that means only one species maybe. Right? So you are mostly looking into these graphs. But when they have told you that competitive exclusion between the species, that means they are talking about two species. Okay? Okay. Now this question. This is again a graphical based question. So an observation was made on a species experiencing three factors A, B, C in order to infer a density dependent population regulation by a factor. The following graph shows the relationship between the adverse effect of the factors in terms of numbers and population density. Yes, Vijayalakshmi, that's why I told you that was my favorite question. It truly tests your knowledge. I mean, not knowledge everyone has because knowledge is very simple concept, but it tests your observation and analysis power, not your knowledge. Okay, now let's see who gives me the correct answer for this one. So an observation was made on a species experiencing three factors A, B, and C in order to infer the density dependent population regulation by a factor. The following graph shows a relationship between the adverse effect of the factors in terms of number and population density. Okay, Malini is saying option B. So everyone analyze. I'm giving you 2 minutes time. Analyze. I want everyone to practice right now. There's a whole point of conducting these Brahmastra series for us. We just don't want to give you the question and give you the answer. But let's prepare it together. Okay, the correct answer here is option B. Look here. For the for this factor A, can you see that after a point of growth, okay, as your population density, the adverse effect is also growing with your population density. After a point of time, it is bending. Can you see it is bending? There is a negative growth here. Okay, so this is your inversely density dependent. Okay, it is inversely density dependent. Yes, beyond a point with population growth, this adverse effect is going to reduce. Okay, so inversely density dependent. Now look the next one, B. There's no like increasing, decreasing as such. Okay, so this is your density independent. And what about the C? It is density dependent. Why? Because with population density, the adverse effect is increasing. Okay, so you can say it is a positive density dependent also if you want to make it very accurate, because A and C both are density dependent. Okay, A is inversely density dependent, whereas C is directly density dependent. With your population increase, C is also increasing. Okay, and in between the B is density independent. Okay, doesn't matter, Malini, you will get the recording, so you can just go through the recordings. Many people joined late also, I see. So you can go through the recordings. Okay, and this is the last question. This is again from the population ecology chapter. So, you know, in population ecology chapter, there are different sections from where you get the numerical based questions. Almost the entire chapter is based on numericals. A lot of numericals, different kinds of numericals can come from there. So, mean and variance, and I'm sure you all have studied about the distribution, right? And in the class also I have mentioned how to calculate the different types of distribution, whether it is clumped or dispersed or it is randomly distributed based on the mean and the variance ratio. Right, so here is the question. They have given you the mean for the three species and the variance for the three species. Now if you remember that note which I had given to you, that hint which I had given to you, remember there was a ratio mentioned: greater than 1, less than 1, equal to 1. Who can tell me what was it? Was it mean by variance or variance by mean? Who remembers? Let's see. Okay. Others, come on. Vijay Lakshmi, yeah, I was expecting an answer. Right. Variance by means. Yes, Vijayalakshmi Malini. Okay. So others who have not been in my class, you have got the hint. Variance by means. Right? So you have to find out the ratio of variance by means and see if it is greater than 1, less than 1, or equal to 1. Accordingly, you are going to get the answer whether it is clump, randomly distributed, or dispersed. I mean, uh, uniform, clumped, uniform, and randomly distributed. So the correct answer, shall I give the correct answer? So the correct answer here is option 1. So variance by mean, if it is greater than 1, if this ratio is coming, I mean, if the ratio is coming greater than 1, it is clumped. Okay. So if you do this, so you have 5.05 divided by 5.3, right? 5.05, I'm doing for species A, divided by 5.3, it is coming as 0.95. Okay, so 0.91 is less than 1, right? Closer to 1 but less than 1. So definitely this is uniform distribution or even distribution. Both are the same. If you take the next one, which is 0.35 divided by your 7.05, it is coming as, the next one is coming as your, for the B, it is coming as your 0.404, which is definitely less than 1. Okay, so this is also uniform. But if you take the C, which is 50.5 divided by 5.30, it is coming as 9.52. Okay, so 9.52 means it is greater than 1, so therefore it is clumped. All right, everyone. So again, I'm telling you, for population ecology portions, don't just focus on the population growth curves. Okay, there are many other sections that you need to focus on. So with this, I come to the end of my 10 question discussion. All right, but since we still have time, let us try two more questions, shall we? All right, before we get into that, uh, have you, is all the questions clear to you? Are all the questions clear to you? Yes? Okay. Then let's, so usually I discuss 10 questions, but I've kept two more questions. Let's see if you can try this. Yes, Shannon and Simpson in calculations, those diversity calculations are important as well. See, in ecology, you have few numericals. Unlike your unit 8, which is your genetics, there is a lot of numericals. Unlike that, unit 10 has got few numericals. Okay, so it's better that you study all the different kinds of numerical problems. the sections, because these numericals are very easy, very easy. Like the variance and means. Did you find it difficult? If you already know what you have to calculate and what you have to look for, that is simple word division that you have to do. That's it. Okay. Now this is a question which is from your unit 10 part A, environment. Okay, it comes under your environment also, and you can place it under your population, that applied ecology also, which is talking about the pollution and all those things. And this is something which is, I will say, based on common sense as well. Like every time we are talking about global warming, all right? Every time we are talking about global warming. So, what can it do? What is the adverse effect that we can face from here? So, the correct answer for this is option two. It results in coral bleaching. So, corals, they are very colorful and they come in different shapes. You will see that the corals, they are turning white. Okay, that is what is known as your coral bleaching. Okay. Next, rise in the sea level, obviously. All right, because obviously the icebergs and all are melting, so obviously the sea levels will rise, and also it will result in a shift in species distribution. Okay, so see, very simple options they have given it to you. Lowering of sea level will never happen. Okay, icebergs are melting. Increase in glacier sheet, how it can be possible when the temperature is so high? So obviously not possible. So this is a very common sense based question. No application, no knowledge also you don't need. If you know what is global warming, a simple definition of global warming, you will be able to answer. So unit 10 can be really scoring and it can be a game changer in your exam. Okay, so do not leave out unit 10. I always tell people, when you're studying the other topics like unit 2, unit 4, unit 1 also, unit 8 and all, those are very complicated topics, I understand. Many people don't understand biochemistry. Many people don't understand genetics. Okay? But Unit 8 is one of the topic. Unit 8 and Unit 11. I will speak for Unit 11 as well. These two are two units which anyone can understand. They are so simple. It just is something which is happening around you, is what is placed in the topics. Okay? It is just coming in the form of the topics. Simply what is happening around you. So it's very easy to relate and understand. Do not leave out Unit 8, Unit 10 and 11 for your exam purpose. Okay, this is the last question. I'm almost to the end of my live class. Now, this is a bit complicated question, but again, this is something dealing with your um, population ecology. Okay, so you have to match the graph. So they are saying three important biological parameters: generation time. Time is how frequently you are reproducing. Okay, or you're generating your population, increasing the population. Population growth rate and the metabolic rate per gram body weight are function of of the organism's body size. Which of the curve represents the correct relationship of each of the parameters to body size? Okay, this is something actually connected to your Environment, Unit 10, Part A also. The correct answer here is option C. Okay. So as your body size is increasing, your generation time will increase. Population growth rate is talking about this. Okay. And your metabolic rate versus gram body weight also is depicted by this particular graph. Okay. So with this, I come to the end of my session here. I hope you have got an idea about the types of questions that you are expected. Okay, apart from this, you get some general questions. All right, some absolutely paragraph based or some direct, as I told you, definition based and all. Okay, but these are the different kinds of numericals and the graph based question that you can get. So with this, I will end the session here. Thank you everyone for joining. Meet you again in another session. Thank you and keep practicing. Bye.